With the idea of marginal physical product of labor and the marginal revenue product of labor in mind, we're going to be able to see what the profit maximizing point for firms are going to be. Remember that MRPL, the marginal revenue product of labor, is additional revenue one worker earns for the firm, while the marginal physical product of labor is the additional output from adding one more worker. There are a few notations that we want to make about MRPL, and a synonymous term that we can use is something known as the VMPL, or the marginal revenue product of labor. So here, do remember that we are working under a competitive labor market where every single firm is seen as a price taker. And the profit maximizing condition was where marginal revenue is equal to price. So this is something that was an assumption that we had all the way back when we were taking a look at market structures. Remember that MRPL is marginal physical product of labor times the marginal revenue. That was the equation that we brought up in the story problem previously. So MPPL times marginal revenue. However, when we substitute price in for the marginal revenue, and we can do that absolutely because marginal revenue is equal to price in competitive labor markets, we get a term known as the value of the marginal revenue product of labor. And that's just going to be another way for us to know MRPL. So MRPL, the marginal revenue product of labor, is exactly the same as VMPL, the value of marginal product of labor. So kind of confusing in this sort of realm, but do be aware that they mean the same exact things for us. And with this idea, we can find that for competitive firms, profits are going to be maximized when labor is hired to the point where VMPL is exactly equal to the wage rate, or the MRPL is exactly equal to the wage rate. So that is the profit maximizing condition that we're going to have under the labor market. And a very typical table that you're going to see is something as such. So 5 columns right here. Column number 1 is the amount of laborers that we hire, say, in our little farm. So 1 farm worker, 2 farm workers, 3 farm workers, all the way down to 10 farm workers. Column number 2 is the quantity of crops or the quantity of output that the workers are going to be able to generate. If we hire 1 worker, he's able to produce 7 units of this good. If we hire 2 workers, both of these workers are able to produce 15 units. If we hire 3 workers, they're able to generate 25 output altogether. Column number 3 is MPPL, the marginal physical product of labor. So that's exactly where the change in Q divided by the change in L come into play. So how do we get to 7? So as we go from 0 units of labor to 1 unit of labor, how much did our quantity change by? We take the difference here, 7 minus 0, and that's where the 7 comes into play. And also because we are typically working with units of labor by 1, the zigzag pattern works very well. 0 plus what number will give us 7? That's 7. 7 plus what number will give us 15? That's 8. 15 plus 10 gives us 25, and then so on down the line. If we sum up the marginal physical product of labor for a particular unit of labor, we can get the quantity. So 7 plus 8 plus 10 will give us 25 units for 3 units of labor. So the same methodology, the same techniques that we built up this entire semester, still very applicable in this market as well. Column number 4 is the MRPL, where the price of this good is equal to $10 each. So all we're doing is taking a look at MPPL and multiplying it by the price of the good. So here, remember that the marginal physical product of labor is additional revenue that the 1 additional worker is going to be able to generate. So we're taking every single number that we calculated in column number 3 and multiplying it by the price of the good. So 7 times 10 gives us 70. 8 times 10 gives us 80. 10 times 10 gives us 100, and then so on down the line. And finally here, column number 5 is the wage rate that we have for every single one of these workers. If we hire 1 worker, that 1 worker costs us $100. We hire an additional worker, that additional worker costs us another $100, and it's going to be a constant wage rate throughout this entire table. With the profit maximizing condition in mind, what's the amount of laborers that we should hire in our farm? You're going to notice that there's going to be 2 places where MRPL or VMPL is exactly equal to the wage rate. So 100 equals to 100 here at 3 workers and 100 equals to 100 here at 7 workers. But which one is more optimal for us? Is it going to be 3 workers or 7 workers? And once again, like we did in the previous chapters, we have to use a little bit of intuition. Does it make sense for us to hire past this 3rd worker? If we hire the 4th worker, how much additional revenue is he bringing in for the firm? He's bringing in $150, but how much did it cost for us to hire this worker? It cost us $100. So does it make sense to hire this 4th worker? And the answer is yes. If He's bringing in $150 for our farm, but it only costs us $100 for us to hire him. He's generating, we're essentially getting $50 in additional profit here. So it does make sense for us to go past this third worker here. So here, this 3 workers would not be the optimal point, and you just continue on with the same intuition. Would it make sense for us to hire the 5th worker? Yes, because he's bringing in $140 worth of revenue for the firm, but it only costs us $100, and then so on down the line. Once we hit the 7th worker, we can see what happens if we want to go ahead and see the 8th worker. Would it make sense for us to hire the 8th worker? And the answer in this case would be no, because the 8th worker is only able to bring in $90 in additional revenue, but it costs us $100 to hire him or her, so it does not make sense to go past that point. So in this case, where VMPL or the MRPL is equal to the wage rate, the optimum point for us is going to be 7 workers. And that's exactly how you should be approaching these type of problems, using this type of intuition to find the optimum point. One final thing that we should note about this particular table comes from column number 3. We notice that the MPPL increases and then starts to decline. And this might seem a little bit unusual because one of the assumptions that we brought up was every single worker was seen as identical and was equally productive as one another. So why are these values sort of fluctuating from high to low amounts? And the answer is because we are still working in the short run within the competitive labor market. So remember that in the short run, we have a fixed amount of capital. So that tells us that every single worker has the same amount of resources and the same amount of capital to work with. And as we hire more and more workers on our farm, they start to get in everybody's way. So remember that idea of too many cooks in the kitchen that we brought up in chapter number 8, 9, and 10. So here, with too many cooks in the kitchen, we do notice to see that MPPL is going to start to decline because of exactly that reason. They have fewer resources and fewer capital, less physical capital to work with. So that is something that we want to go ahead and note about that column number 3. We should note that when firms hire additional workers, MPPL will start to decrease. Marginal physical product of labor will decrease because each worker now has less capital, and fewer resources. Will pay less resources to work with. So less capital and less resources to work with, basically showing us why column number 3, the MPPL, is declining as we hire more and more workers. Remember that the most important part of this section is that the marginal revenue product of labor equals the value of the marginal product of labor, which equals the wage rate, which will tell us exactly the optimum point of profit for the firms and corporations and tells us exactly how many workers to hire within their organizations. We'll go ahead and take a closer look at the demand side of labor a little bit more in the next few videos.